solving two-step equations is our topic for today. So remember with one-step equations, we had something like x plus 11 equals 32. We would subtract 11 from both sides, and we get x equals 21. If it said x minus something, we would add to get our answer. So here's kind of one type of one-step equations, is when we're adding or subtracting. And then there's another type, which is if we're multiplying or dividing. If I have something like 3x, oops, almost gave you a two-step equation. 3x equals 36. This means 3 times x. So I divide by 3. And we have different ways of writing it, either like that, or if you would rather, you can write it like this. Divided by 3. Who likes writing it this way better? Raise your hand if you like this way better. Okay. So I guess we'll use
what's
that
the other
one.
way?
The other way is like this.
Oh, I like that way better.
I like the first way.
I like that one.
Raise your hand if you like the first way better. Raise your hand if you like this way better.
That one's less first way.
It's easier
Yeah,
for
I
these
understand
problems.
it's division, so it's easier.
Okay. Let's write it like this.
Easier for these types of problems.
I think it's good to write it like this because it helps us remember that every fraction is actually a division problem. And the other nice helps us practice canceling. So we see like the 3 over 3 and we cancel it.
Do you do
Then
that?
we have x equals 36 divided by 3 is 12. Now remember, you can always over on the side just write 36 divided by 3 and you would get 12. This marker is back. Alright? So show whichever work you need to. Sometimes you'll want to show this, sometimes you may not need to. Right? If it's 10 divided by 2, you can probably remember that that's fine. Alright. So a two-step equation is just going to combine both of these together. Okay? We're going to sort of combine the 3x and the plus 11 into one equation. So let's say I had 3x plus 11 equals 41.
Are we still solving for x?
We're still solving for x. So our goal is to get x all alone. That's what we want to do. We still have the same tools. We're going to add, subtract, multiply, or divide. But now there's two things in the way. We have 3 times x and we have plus 11. Yeah?
Okay, so because it's addition and multiplication, would you divide by 3 first for all of them, and then whatever 11 ends up being, you subtract by that to get your answer?
You could totally do that. There's not one right way of solving this, okay? There's not one right way. There is a shorter and easier way, okay? The shorter and easier way is going to be to get your x term alone. Yeah.
Would it be possible to solve for x by doing this? This is like something I learned in like 3rd grade. Doing like 41 minus 11 equals what 3 x's? Okay. Is that the simpler way?
Yeah, that's going to be the shorter way. The shorter way is always going to be if we get this alone first. So instead of trying to get x alone, we're trying to get whatever x is with alone. Okay? Yeah.
So these aren't distributive properties.
We're not going to have to use the distributive property really for this. Okay, good question. So I'm going to subtract 11 from both sides. That's going to let this sit alone on one side of the equation. So I have 3x plus 11 minus 11 is 3x equals 41 minus 11 is 30.
And then you divide.
And then I divide.
Gosh.
Divide by 3 so that I get x all alone, x equals 10. Okay. So I'm always going to try to do my addition and subtraction first, then my multiplication or division. Now, I say that's going to be true on your homework. There are cases where that won't work. So you just have to remember our rules about solving equations. Now, what if we had tried to do this the other way? Let me show you why I want you to add or subtract first. It's not because it's better or it's right, but it is easier. Oops, yeah, 41, right. Thank you. So let's say if we divided by 3 first. We divide both sides of the equation by 3. So we have 3x plus 11 over 3. Well, in order to divide this by 3, I have to divide this by 3 and divide this by 3. Well, 3x divided by 3 is x. 11 divided by 3 is 11 thirds. I guess we could write it like that for now. And then over here I have 41 thirds. The key is I can't only divide this by 3. I have to divide the whole side of this equation by 3. Now I can get my x alone if I subtract this 11 thirds. So x is going to equal 41 thirds minus 11 thirds. So that's 41 minus 11 thirds. Now 41 minus 11 is 30 thirds. Oh, and 30 thirds, that's the same as 10. So I do get the same answer in the end, but there's more steps to getting there, and we're going to deal with more fractions in getting there. Okay? If instead we get our x term alone first, and then divide, we'll have a simpler process to getting our answer. This worked. I still got x equals 10. It's also very easy to make mistakes when you do this, though, because some people will go, oh, divide by 3. I'm going to only divide the x by 3. I'm just not going to divide that by 3, which is not allowed because of the distributive property, actually. We're not going to get into that today. I have to divide the entire thing by 3, and that would be a very common place to make a mistake. With this method, I think this is a lot easier to not make a mistake, and there's only really 2 steps, whereas here, because of the fractions, we have more steps. Let's take a look at some other 2 steps. 2-step equations. Alright, let's say I had something like this. 2x minus 35 equals negative 3. What's our first step? Yeah.
So you're going to divide 35 by 35.
I want to get rid of the 35. This says 2x minus 35. What's the opposite of minus 35?
Addition, sorry. You add 35 to that side.
If I add 35 to this side, I'm going to get my x term all alone.
And then you do it to the other side, and then you get your answer, and then you, what's it called? You divide.
Wait, you're getting a little bit ahead of me. So I have to do this to both sides.
Yes.
2x is what's left on the left. On the right, I have negative 3 plus 35. What's the answer to that? 32. Am I done?
No.
I don't have x all alone yet.
Divide.
Divide! This means 2 times x, so I divide by 2. And I get x equals 32 divided by 2 is 16.
Yay.
And I put my answer in a circle or a box so that
Circle.
Nate can find it on the page.
Circle.
Whichever one you like to do. Sometimes I do kind of like the box circle, like I start boxing and then I circle the end. As long as I can obviously see, okay, this is my answer. Yeah,
Can I use that sheet?
sure. All right. Let's do some more examples. Can I erase this?
Yeah.
How about this? 5x plus 3 equals. First step. Yes.
You subtract 3 from read and the answer.
Subtract 3 from both sides.
Yeah.
5x plus 3 minus 3 is
15.
5x.
Equals 15.
18 minus 3 is 15.
And then you divide 5 by 5.
5 times x, the opposite of times is division.
3.
X equals 3. Here's my box. That turns into a circle. That's how Nate knows what my answer is. The circle box.
It's amazing.
Alright, let's look at some other ones. What if I had something like this? X over 7 minus 23 equals negative 16. It's my first step. I want to get my x term all alone. So what's my first step?
Multiply 7.
I could multiply 7. And actually in this case it would actually be the same amount of steps. But because of the way that we're doing these, I want you to start with this. Okay? So I want to start by getting rid of the minus 23. The way you said to solve it is totally fine. It will work 100%. You'll get the same answer. I'm just asking us to focus on this first so that we learn the procedure of kind of isolating the x term. So how do we get rid of the minus 23?
You add 23 and then you add it to the
Add
other side. And
23.
it's basically the same thing. It's just x over 7.
To both sides. Now I have x over 7. Negative 23 plus 23 is 0. Negative 16 plus 23 is
39.
7. I have a negative number plus a larger positive number. I'm going to get a positive number that's the difference between them. Okay, now I have to get x alone. Now what do? Take rid of this divided by 7.
You get times 7.
Yeah. 7 times this side times 7. These will cancel out, leaving you with just x. 7 times 7 is
49.
49.
Is that a plus or a times with 23?
That's a plus.
The same as the other one?
Yeah.
Okay.
He writes plus times.
Alright, so yeah, I usually write my multiplication with just a dot.
Okay.
Partly because the x's also look like multiplication signs. I could have written these a little straighter though.
Yeah, that's what I was confused about. Just a bit crooked.
I make mine kind of star when I.
Alright. Let's try another one. 1/3 x plus 11 equals negative 9. Yeah. What am I going to do first?
Subtract 11.
Subtract 11. I want to get that x term all alone. I want there to be no plus or minus signs around x. So I just have 1/3 x plus 11 minus 11 is still 1/3 x. Negative 19 minus 11
30.
Those add up to 30. Is it positive or negative? Yeah, I'm adding together two negative numbers, right? Subtraction means adding a negative. So I'm combining together, I'm adding together two negative numbers. I'm going to get a larger negative number. Negative 19 minus 11 is negative 30. Oh, but there's still something in the way of x. How do I get rid of that? Yeah.
Divided by 1/3.
Divide by 1/3, which is the same thing as multiplying
3 over 1.
by 3 over 1. What number is 3 over 1?
The same thing.
It's just 3. So I'm going to just multiply by 3. Right? I'm kind of ignoring the over 1 because it doesn't make a difference. 3 and 3 over 1 are the same. This will cancel out. Boom! Leaving me with just x over here.
Equals negative 9.
Negative 30 times 3 is negative 9. When we're multiplying, a negative times a negative is a... Right. So when multiplying, you can, I'm going to write this out in shorthand. You can choose to write it in shorthand, or you can write it out a little longer. A negative times a negative equals a positive. Right? What about a negative times a positive? What does that equal?
Negative.
Negative. How about a positive times a negative?
Negative.
A negative. What about a positive times a positive?
Negative. Positive.
Let's do an example of each one. A negative times a negative. Let's say I had negative 7 times negative 8. What does that equal? So 7. A negative times a negative is a
Negative.
positive. 7 times 8 is 56. Okay, a negative times a positive. Let's say I had negative 4 times positive 6. Is this going to be a negative or a positive answer? Negative. What is 4 times 6? 24. Positive times a negative. Let's say I had 12 times negative 11. 12 times negative 11. Is that going to be a positive or a negative? A negative. What is 12 times 11? One 32, right? The way I don't actually I don't have this one memorized, but I know 12 times 12 and I know 12 times 10. 12 times 12 is 144. 12 times 10 is 120. And this is just 12 less than 144, or 12 more than 120. Or you can just try to memorize. 12 times 11 is 132. 12 times 11 is 132. Alright, and a positive times a positive, let's say I had 11 times 7. What would that be?
77.
Make sure that's all in your notes.
Question.
Yeah.
Well, when with a negative times a negative equals a positive, wouldn't that not always be true because depending on the numbers?
No, it's always true.
Okay, is that only when it's adding and subtracting? Okay,
Yeah.
sorry.
Yeah, when we're multiplying. You're totally right. If you were adding or subtracting, then this depends on what your numbers are. All of these, well, yeah, let's not, I don't want to confuse you by talking about that right now.
Gotcha.
We've been practicing that one. We practiced that a couple weeks ago,
Yeah.
right? now we're just reviewing when we're multiplying. A negative times a negative is a positive. A negative times a positive is a negative. A positive times a negative is a negative. A positive times a positive is a positive. And your homework is going to go into this as well, right? Have you practice that. So, look at this equation. 5x plus 3 equals 18. We needed x all alone, but there are these other numbers in the way. The first thing we do is try to get rid of all of our plus and minus signs. Boom. 5x equals 15. The next thing we do is we multiply or divide to get x all by itself. Right? It's like doing two one-step equations in a way. And we just remember we're going to add or subtract first. That's how we're going to do these problems. Is it the only right way to do them? No. Are there other ways to solve these? Yes. Right? But this is the procedure I want you guys to practice tonight, is getting used to, I'm getting rid of this, then I'm getting rid of this.
Thank you.
Good.